So here we have two goods, X and Y, and a couple of budget lines and a couple of indifference curves. We also given the slopes at some points, so let's see what's going on. Suppose the price of good X is $4, the price of good Y is $3, and the consumer's income is $180. So let's look at that case first. If you have a total of $180, the price of good X is 4. What is the intersection of the x-axis? Right? It costs $4 and you have 180. The intercept is 45, right? So basically, if you spend all your money on the good X, you can buy 45 of them. So we know we're here. And then good Y is 3, right? If you spend all your money on it, then you can buy 60. So we're basically on this budget line first, right? And we know that we see from the picture that since we're on this budget line, our optimal point is B, right? This is the highest indifference curve that we can reach while still in the budget, right? Because they're tangent. Right. Now the price of good X drops to $2, right? If it drops to $2, what's my new intercept? 90, right? Because income is the same, it's 180, but now I can buy more of it. So basically there is a counterclockwise shift of the budget line, right? Moves from that budget line to that budget line. And what's my new optimal point? A, exactly. Right, so I was first at B, then the price of X fell, now I end up at A. So this is quantity Y1, this is quantity Y2, right? This is the original quantity, this is after the change in price, and this is quantity X1, and where is it? Here somewhere. Quantity X2. All right. Which of the following statements represents the income effect? All right. What do you think?
E to A.
Sorry?
E to A.
E to A. That will be correct. So we know the substitution effect is moving along the same budget line, along the same indifference curve to a point where the slope is going to be the same as the slope of the new budget line. So which then represents the substitution effect? The substitution effect is, as I said, it's moving along the same indifference curve to a point B to E. Right? So this is the substitution effect. And why E versus D? Because we need the slopes to be equal, right? The slope here we are told is negative 2/3. And we can also look at the slope of the new budget line, right? It is 6/9, or 2/3 as well, right? So the slope of the new budget line is negative 2/3. The slope at E we're told is also negative 2/3. So that the substitution effect will be moving from B to E, and then the income effect is from E to A. This is substitution, this is income. Okay? Now, so given the information, which of the following statements is true? So are the goods complements or substitutes? And can we tell whether they're inferior, is Y inferior, is X inferior? Which one of those do you think is true? I think there's substitutes. Okay, so let's reason through this. Basically what happened here is with the shift in the budget line, is a decrease in the price of X, right? That was the scenario. So price of X goes down. In order to tell whether they're complements and substitutes, we need to see what happened to the quantity of y, right? Because this is the cross elasticity basically we need to calculate. So the price of x went down. What happened to quantity y? The quantity consumed of y. Did it go up or did it go down? It went down, right? So we moved from B to A, and we ended up with a lower consumption of y than we started with. So price of x goes down, quantity of y goes down as well. So are they substitutes or complements?
Substitutes. Substitutes.
I'm not sure. What is it? Price goes down, quantity goes down. Substitutes, right? Right. Because it's cheaper now to buy X, so more people buy X, less people buy Y. If you think of Coke and Pepsi, if Pepsi is cheaper, then I'm gonna buy more of it and less of what is it called? Right? Alright. Right. Ignore the budget lines drawn in the figure. So let's ignore this as well. Ignore the budget lines drawn in the figure. If bundle E is optimal for this consumer, so if the budget line is whatever, such that bundle E is optimal, and good X costs $1, so price of X is $1. How much does good Y cost? What do we do here? I don't have a budget line to look at, right? But I do know that my optimality point is E. What do I know is true at the optimal consumption bundle?
The slope is equal to the marginal rate of
Substitution. Yes, exactly. So the slope of the budget line is equal to the marginal rate of substitution at the optimal. And this is the slope budget line. What is the marginal rate of substitution at point E? Right. The marginal rate of substitution is basically the slope of the indifference curve. And here I'm told that at the point E, the slope of the indifference curve is 2/3. How do I measure the slope of the budget line? What was the formula for that?
Y over X.
X over Y. Changing Y over X.
What variables am I given? I'm given the price of X and I'm looking for the price of Y. Does that point you in the right direction? What's the slope of the budget line?
Price of X over price of Y.
Exactly. And that's all you need to know here. Right? I have this, and now this is 1, I need to solve for that. Right, both of them are going to be negative, right? But we can ignore the negative. So this is 1, so what is the price of Y? A. Yes. No, wait.
C.
The other way around, C. Well, so cross multiply, right? This is 1, basically. This is 1. So 3 equals 2 py, py equals 3 over 2 or 1.5. C. Okay? So here all you need to know is that the slope of the budget line is the relative price. It's price of X over price of Y. And that at the optimal point, marginal rate of substitution equals the slope of the budget line. So there's 2. Okay, if the price of good X is 1, the price of good Y is 1.5, and the consumer has an income of $90, what is the consumer's optimal consumption bundle? Right. So they have $90, right? If they spend all of it on X, how many can they buy? So first intersect is here. And if they spend all of it on Y, how many can they buy? At 1.5. 60. So basically we're told that we are on this budget line. And the question is, what is consumer's optimal consumption bundle? A. Right? Simple as that. Alright. So now we're going to change things for a little bit. We're going to call X consumption. And Y is going to be leisure. So if good X is consumption, good Y is leisure, or free time, what can we say about this consumer's labor supply curve? Now, what is labor supply curve? This is basically wages against labor, right? So at which way, at different wages, how many hours or whatever am I willing to work? So we need to say something about the labor supply of this consumer, given that this is leisure and this is consumption. So what do we know happens? Let's assume we are in this budget case, right? And we're at the optimal point of B. What's going to happen if wages go up? So here you can basically think of leisure as 1 minus the number, or 1 minus the percentage of time that you spend working, right? So let's say you have 1 hour to work or to do whatever, right? Not to work. Leisure is that 1 hour minus the amount of time that you work during that 1 hour, right? So if wages go up, so you paid more for the amount of time that you work, at any point you would be able to get more goods, this is consumption, right? For the same amount of time worked. So let's say here, this is how much time I spent. This is my free time, so this is also the 1 minus the amount of time that I work, right? So at this point, if wages go up, basically for the same amount of work that I'm putting in, since I'm getting more per hour, I can buy more stuff, right? So basically I can buy more goods. And when wages go up, we're going to see a shift of the budget line pretty much as the one that, similar to the one that we have here, right? Is going to shift counterclockwise. Right? So if I spend all my time working, right, before I can buy 45 consumption units, whatever, like you can think of as a consumption bundle. Now because I get more money per hour when I work, I can buy 90 of the same consumption bundle. Does that make sense? All right. So we know that the end result, as we already saw, is going to be a move from B to A. And this is as wages go up, right? So as wage goes up, what happens to my leisure, my Y variable? We just saw that before. It goes down, right? My free time goes down, which means that, am I working more or less? More. So basically, as wages go up, my labor goes up as well, which means an upward sloping labor supply. Agreed? Right. So let's do it.